Mute yourself. So thank you for joining immediately. Right here, everyone got idea about focal length, radius of curvature. That means terminology of the mirrors. So for the convex mirror or concave mirror, terminology is same. For any mirror, terminology is same, but maybe they are located opposite sides. Right, as we said, F and C located behind the mirror for convex mirror, in front of the mirror for a concave mirror. So up to here, clear? Not following. Okay, very good. So now we'll go for another one. Here, to obtain the image, for example, in the activity 2, we will get a image on the paper of sun. Right, that bright spot is what? Sun image on the paper we obtained. So can you explain that formation of image by the diagram? Yes, we are able to explain. But here, to explain that, we need to have an idea about the behavior of certain light rays. So that we can call it as rules to draw the ray diagrams. Right, that we can call it as rules to draw the ray diagrams. So here now I'm giving you the rules to draw the ray diagrams of a concave mirror, right? So that we can use to draw the image of any object which we keep in front of the mirror, for any mirror, right? So separately we will discuss the rules to the concave mirror and related to the convex mirror, right? So what they are? So here that rules are simply help us. The following rules can be used to guess the position of the image formed by a concave mirror. It is especially for the concave mirror only, right? So here for this, just you have to follow the rules. What? First, drawing the horizontal line on the paper, right? Then cutting the arc using, I will give you the logic. Always you need to open your compass. Open your compass for the radii is equal to 12 centimeters. Right? 12 centimeters. So by opening that 12 centimeters gap, so put your compass needle at this point, right? As center of curvature. Then cut the arc. Radii is equal to 12 centimeters. So here it is pole. Then where you can identify your focus, where I have to identify focus, because already I gave you relation
6 centimeters.
F equal to small f equal to R by 2. So R equal to 12, then by 2 at 6. So here at exactly middle 6 centimeters. So this gap same. 6 and 6. So it will help you in drawing the ray diagrams. So follow this logic. Okay. So let us go for the first rule. What is that first rule? Here simply we are going to select the parallel light ray to the principal axis to incident on the concave mirror. So if a ray parallel to the principal axis and incident on a concave mirror, what happens? So already the generalization given you. So how to follow that? I will represent you as here on the screen. So look at that on the screen. So first of all, drawing the horizontal line on the paper using the scale, right? Then what to do? Select the center of curvature, opening the compass 12 centimeters. Then from the center of curvature, you have to cut an arc and make it as a concave mirror, right? Then what to do? Identify its pole and name it as P, that point. Then what to do? Select a ray which is parallel to the principal axis and incident on the concave mirror. So put your scale after identifying the focus here. So focus distance is what? Equal, right? Middle to the pole and the center of curvature. 6 centimeters left side, 6 centimeters right side from the focus. Okay. Then use your scale as you see on the screen to draw the parallel ray easily. No need to measure the gap, parallel width of the scale. Are you clear? Quick reaction. Is it clear? Why I'm using always the scale like this? To get the parallel ray easily. So now complete the ray to incident on the mirror surface. So now remove your scale. Then what to do? Measure the angle of incidence, right? For the incident light ray with the normal. So draw the normal, right? This is the normal. Then measure the angle of incidence using the protractor here. So how much it is showing? Almost it is equal to 14. Can you see that? So identifying a point at 28 centimeters for angle of reflection. So at 28, I used a red color pointer, then remove your protractor, then join the point of incidence and this red color spot using the scale to trace the reflected light ray with the same angle of incidence, reflecting back with the R. Right? Is it clear, everyone? How I drawn? So this you have to verify mathematically actually. So where that ray meets the principal axis? Anyone answer? Answer, anyone? I got here 14 degrees angle for the angle of incidence. I also used 14 degrees angle for the angle of reflection. So here through this spot, this reflected ray is passing. But look at here, one more spot is available. What is that? What is that? Can you see or not?
Focus.
Focus. So how the reflected ray is after reflection? It is passing through the focus. Yes or no? Right? It is passing through the focus. Look at that. See here. Angle of incidence is 14 degrees. Angle of reflection also identified as 14 degrees. Then if I draw a line, exactly it is passing through the focus. Look at that. Is it clear? Everyone, is it clear? So you can verify this mathematically. Choose a light ray, incident light ray parallel to the principal axis as you see here. Right? So I chosen a parallel ray using scale by placing like this. Then drawn a line, that means a ray incident on the mirror. Then I use it normal to measure the angle of incidence here. That angle of incidence is measured by me as 14 degrees here. So I written that angle of incidence here. Then identified the same angle of reflection 14 degrees opposite side to the normal. Then identified a point, red color spot. Then drawing the reflected light ray here. So when I draw the reflected light ray, I observed it is passing through the focus. Right? So with the same angle of reflection. So this is I verified mathematically using the ray theory. So what is I am giving the generalization here? If a ray parallel to the principal axis incident on a concave mirror, then it passes through the focus of the concave mirror. Right? After reflection, it passes through the focus. Is it clear, everyone? Any confusion? If it is clear, we will go for the second rule. Everyone, give your response. Right? Thank you. Right. Now I'm going for the second one. Right? So what is the second rule here? So if I choose a parallel ray, it is moving through the focus. S. That is rule 1. Yes or no? This is I am given as rule 1. So this I said that ray which you incident parallel to the principal axis given as R1 here. Right? So I'll keep this as it is for your understanding purpose. Then what I'm doing here, it's conversion, means parallel passing through the focus if it is passing through the focus, what happens? Right? It's conversion. Second rule is what? It's conversion. Am I clear? Am I clear? Right. So I'm going for the second rule now. So rule 2. It is rule 2. That rule 2 is what happens if a ray of light which is passes through the focus of a concave mirror. That is my question. So generalization we will verify. I am not reading that generalization first. We will go for the geometrical diagram method. So first of all, drawing a principal axis, identifying the center of curvature using radii 12 centimeters, cutting the arc now, right? Then making it is as concave mirror. Then identify the focus. Next, identifying the pole, name it as P. Then what to do? Identifying its focus, name it as capital F. Then draw a line. That means a ray incident on the concave mirror, that which is passing through the focus. Now look at how to place your scale. So join the mirror surface and focus above the principal axis or below the principal axis, whatever it may be. Right? You can take like this also, not a problem. Put your scale like this also, not a problem. Below. I'm taking above. You can take below. Not a problem. Right? So simply I chosen this direction. Then selecting a ray that which is passing through the focus and incident on the concave mirror. Look at here again. Incidenting a light ray on the concave surface that which is passing through focus. Is it clear up to this point? Quick reaction. Right. After reflection, what happens? For this, we need to measure the angle of incidence and angle of reflection using the normal. So I am drawing the normal to the point of incidence. Then what to do? Using the protractor, you have to measure angle of incidence, right? So how to place the protractor to measure angle of incidence and angle of reflection at a time? So like this. Clear? So what I am observing, it is almost equal to 15 degrees now. Angle of incidence is showing 15 degrees. Then what to do? Angle of reflection also I need to measure 15 degrees. That is 30 degrees line. Right? That is. Then now identify that with a point. Then complete angle of reflection. Then draw a line by joining the point of incidence and identified a spot here. Right? Then completing the reflected light ray. Then verify your drawing. Is it parallel or not? So I placed a scale. So exactly how you are observing? Answer me. How it is that reflected light ray to the principal
Parallel.
light? Very good. It is become parallel. Now you look at generalization here. What we are generalizing. Is it clear, everyone? We verified with the drawing. This generalization becomes parallel to the principal axis after reflection if a ray passes through the focus. Is it clear? Is it clear? Everyone. So its conversion also true. If there is any issue, unmute and ask me. Right? So remember in the same diagram. Now I am showing you how to remember that in the same diagram. Right? Right. So I remove the scale. If a light ray incident like this, it goes like this. If a light ray, I'm using different color for showing you, like this, then it goes after reflection like this. So in the same diagram, we can remember if a ray is maintaining this direction, reflects like this. If a ray maintain this direction, it reflects back like this. So in the same diagram, we can see the two rules. Is it clear? Quick reaction. Is it clear? Two in the same diagram. Right, thank you. Then we'll go for next rule. Third rule. So what is that third rule? So two completed. What there? One is parallel to the principal axis, incidenting on the concave mirror. Second one is passing through the focus. Now I'm going for the third one. That is simply incident on the mirror, concave mirror, along the normal. If a ray of light passes through the center of curvature or along the normal. This is the condition. Passes through the center of curvature or along the normal. Then what happens? Right? That we have to verify with the diagram. Generalization I am not reading. First only given the generalization. That generalization I am verifying with the drawing. So look at same method I am following. Drawing the principal axis, identifying the center of curvature, opening the radii 12 centimeters, then cutting the arc, making that arc as concave mirror, shading its convex surface, then identifying the pole, naming it as P, then using focus to represent as F, then cutting the normal first. Right? Then what is our condition? A ray of light passes through the center of curvature. Now I am drawing a ray that which passes along the normal. Can you see that? Answer me. Can you see the light ray? How incident on the mirror? Answer me, anyone. How the light ray is going to be incident on the concave surface or convex mirror, concave mirror? Anyone?
In the path of normal.
Along the normal, or if you imagine this light ray is coming from this way. So it is passing through the center of curvature. Anything is correct. Are you clear? So it is looking like passing through the center of curvature or along the normal. So I think no confusion. Right. So now we have to complete. Can you measure angle of incidence here? What is the angle of incidence? Anyone? Angle of incidence is equal to what? Is there any angle between the incident light ray to the normal? Anyone? Sri Charan. What is the angle here? Angle of incidence?
0 degrees.
0 degrees. Kaushik, what is the angle of reflection?
0 degrees.
Why 0?
From the center of curvature.
According to law of reflection. Don't forget this one. Everywhere we are applying this, but we are not saying directly. Okay. So according to law of reflection, angle of incidence is equal to angle of reflection. That both are 0. So where the path of reflected light ray will be? Right? See here. Along the same direction. Along the same direction. So you are unable to see that. I am using the different color for that. So it retraces its path like this. Can you see? After reflection, it retraces its path. So this is the generalization. Look at here. The generalization written here. So if a ray of light passes through the center of curvature of a concave mirror, then it reflected back along the same path. Is it verified or not? Answer me. Unmute and answer me.
Yes, sir.
Right. So in this case, ray of light falls normally on instance. So the light ray which is passing through the center of curvature or along the normal, that we can say incident that light ray on the surface is normally. So if their light ray incident normally on any mirror, on any type of mirror, what happens? It reflect back in same direction. This is the generalization. Are you clear, everyone? Is it clear? Right. So we will go for the next rule here. Actually, in your textbook, 3 rules only there. I'm giving you the 4th rule. Right? So what is that 4th rule? Here the 4th rule is, what happens if the light ray incident at pole? At the pole. Right? So look at in the diagram. At the pole, I am going to incident a light ray on the concave mirror. Point of incidence is chosen as pole here. Right? So the same process I am following here. No difference. Then choose the light ray to target onto the pole from any direction. From the below also. So incident light ray is selected. Is it clear? Use your quick reaction. Is it clear? So now the light ray meets the pole. Then what to do? Here we have to verify we have to use the law of reflection. Angle of incidence will be equal to angle of reflection. Then what to do? Here, measuring the angle of incidence. So where will be the normal for this light ray? Anyone? Anyone? I want normal to measure the angle of incidence. Which is normal at this point of
Principal axis.
Principal axis only, right? Because it is connecting these two straightly, right? So that's why this principal axis only act like normal. So this is only normal for us. So where I have to measure the angle of incidence between the incident light ray and normal. So that I am showing you here. This is angle of incidence. Then what to do? Measure the angle of incidence and angle of reflection at a time by placing your protractor like this. Right? So what is the angle of incidence? It is almost 15 degrees. Then what to do? Measure 15 degrees another side to the normal, below it. Because it is above, now I am measuring below. Right? So now what to do here? Identifying a point at 30. So clear? Quick reaction. How to measure the angles at a time. Are you clear? Following me? Yes, thank you. So here now, measuring the angle of reflection here. See, I'm showing you below the principal axis. Now removing the protractor. Then what to do? Join the point of incident and the point you recognize it to trace the reflected light ray. This red color point. Then put your scale like this by joining the pole and the identified point. So now draw the line that which shown as ray. So I got reflected light ray. Right? So like this, we can follow the rule number 4. Is it clear? Is it clear, everyone? Any confusion is there in the rules? So now I am writing you the figure numbers on the screen for these rules where you have in your textbook. R1 for the concave mirror is in the page number 7. Page number 7, figure 8. Then R2 is given in the page number 8, figure number 9. R3 is given in the page number same 8 and figure number 10. Can you see them now? See your textbook. That I explained. That I explained. Right? So this is the topic for today's discussion. Right? So if there is any confusion, give me. Just individually. Tejaswini, unmute. Any confusion in today's class?
No, sir.
Thank you. You can leave. Kaushik, any confusion? No confusion? Now you can leave. Rohit, how do you feel?
So good, sir.
Thank you. You can leave. Vikrant, is it clear?
Yes, sir. Clear.
Thank you. Leave. Sricharan,
Sir, clear.
thank you. You can leave now. Abhinay,
Sir, clear, sir.
thank you. Tejashwini, you can leave now. Savan,
Sir,
Clear, sir.
okay. Abhinay, you can leave. Sricharan, you can leave. Tejashwini, do you have any doubt?
sir, please change the timing, sir.
What is convenient for you actually?
Sir,
Your convenient time?
evening, sir.
ఈవినింగ్ అంటే కుదరదమ్మా, ఎందుకంటే నేను నైట్ క్లాసెస్ లో ఉంటాను. మార్నింగే కుదురుతుంది. కావాలంటే 6 కు పెట్టమన్నా పెడతాను, ప్రాబ్లం ఏం లేదు.
Okay, sir.
ఓకే సరే, ఒక 2-3 డేస్
7 to 8 up to 8 keep, sir.
మార్నింగ్ 6 to 8,
6.
బిలో 8,
Before
8 AM. Okay, no problem. We'll manage. Just adjust 2-3 days. We'll manage the time. Okay, right. Surajita,
Sir,
clear?
clear.
Thank you.
Clear.
Medashri,
No doubt, sir. Clear.
thank you. You can leave everyone. If anybody remaining to give your response, just unmute and talk. Otherwise, leave. Tejashwini, okay.